Welcome to the Explainer. Okay, picture this, a skyscraper that looks like it's draped in a green waterfall, or an office lobby that feels more like a lush, vibrant rainforest. These are living walls, and they look absolutely stunning, but they are so much more than just decoration. Today, we're going to pull back the curtain on the incredible engineering that actually makes them work.
You've definitely seen them, right? These massive green tapestries covering the walls of fancy hotels or corporate headquarters. They look amazing, but you have to wonder, how on earth do they keep something like that alive on the side of a building?
All right, let's get right into it, because what looks like a simple, beautiful piece of decor is, in reality, a seriously high-performance machine. We're talking about a fascinating mix of biology, structural engineering, and some very clever water management.
So why even go through all this trouble? Well, it taps into something deep inside all of us called biophilia. It's basically our innate instinctive love for nature. And bringing the outdoors in like this, it's not just about looking good. It turns out it has some really profound benefits for us.
And the promise of all this is pretty incredible. We're talking about scientifically documented stress reduction, helping us focus better, and even making the building itself perform more efficiently. The plants act like a natural layer of insulation, and they can even cool the air around them. It's a really powerful vision.
That is the million-dollar question, isn't it? Because you can't just stick a garden on some drywall the way you'd hang a painting. And this, right here, is where that beautiful dream smacks right into a very, very harsh reality.
You see, every single living wall project, no matter how beautiful it ends up, has to solve two massive engineering challenges first. And those are weight and water. If you get either one of those wrong, you don't have a beautiful feature, you have a structural disaster waiting to happen.
So let's start with weight. I mean, think about it. A few potted plants, no big deal. But what about hundreds of them, all packed together with their soil, plus the structure holding them up? And what happens the moment you water all of them?
Because here's the thing. The real weight isn't just the plants in the frame. The absolute killer is the water. When that growth medium is fully saturated, right after an irrigation cycle, the load just skyrockets.
We are talking about a load of up to 120 kilograms per square meter. To put that in perspective, that's like hanging a full-grown person from every single square meter of that wall. This is exactly why a structural engineer is non-negotiable. You have to anchor this thing directly into the building's main structure.
But, okay, let's say the wall can hold the weight. The water itself presents an even bigger threat. Having constant moisture right up against your building's structural supports is just a recipe for mold, rot, and eventually, catastrophic failure. This is the #1 reason these projects go wrong.
So now that we know the stakes are incredibly high, how do the pros build a system that can handle all that weight and safely manage all that water day in and day out for years? Well, they don't build a garden, they engineer a living machine.
Job number 1 is creating an absolutely impenetrable barrier. We're talking about industrial-grade materials like EDPM rubber, the same stuff they use on commercial roofs, installed like a shield between the green wall and the building itself. The best systems even include an air gap behind that shield, just to make sure any stray condensation can evaporate harmlessly.
So how do you actually deliver the water without soaking everything? The solution is a closed-loop system. Think of it like a circulatory system for the wall. A pump in a reservoir at the bottom pushes water up to distribution tubes at the top. The water then trickles down through the plants, and any extra is collected by a gutter and sent right back to the tank to be used again. It's smart, efficient, and most importantly, it's contained.
And this, right here, is why the gap between a little DIY project and a professional installation is just so vast. A simple felt pocket system might look okay for a year or two, but they are incredibly prone to leaks and failure. Professional modular systems, on the other hand, are engineered from the ground up with all these risks in mind, which is why they can last for a decade or even longer.
Okay, so we've built the hardware, right? We have the structure, the waterproofing, the plumbing. But a machine is pretty useless without the right software, and in this case, the software is the plants themselves.
You can't just stick any old houseplant into a vertical wall and hope for the best. You need plants that are tough, have shallow root systems, and can handle the unique conditions. That's why you almost always see plants like pothos and philodendron. They're incredibly hardy, and their trailing vines are perfect for covering the hardware. Then you have things like Boston ferns to add that really lush, dense texture.
And because they're all packed in so tightly, it basically becomes a miniature jungle, a constant battle for resources. The faster-growing plants, like pothos, will actively try to grow over and shade out their neighbors to get more light. This is why regular maintenance isn't just about keeping it looking neat, it's about managing this competition and keeping the entire ecosystem healthy and in balance.
And speaking of light, indoors, it's the single biggest challenge. You can't just guess, it has to be engineered. Professionals use specialized equipment to measure the exact amount of usable light hitting the leaves, that's the ppfd, and then they install special grow lights on timers to deliver a precise dose of light every single day.
So, we've seen the incredible amount of engineering that goes into these things. But here's the cool part. Once you get all of that right, the living wall transforms from a fragile decoration into a high-performance piece of the building's infrastructure, and it does some truly amazing things.
Take sound, for example. In a loud, echoey, open-plan office, a living wall acts like a giant acoustic panel. That combination of the porous growing material and all those soft, irregular leaf surfaces can absorb up to 85% of the ambient sound. It makes the space dramatically quieter and calmer.
And this is a really crucial point. We've all heard that plants clean the air, but honestly, a few potted plants have a pretty tiny effect. Active living walls are a completely different ballgame. They use fans to actually pull air through the root zone of the plants. Down there, an entire ecosystem of microbes goes to work breaking down pollutants, removing over 90% of certain harmful chemicals in just a single pass.
So, the next time you see one of these magnificent walls, you'll know you're not just looking at plants. You are looking at a structurally engineered, waterproofed, hydroengineered, and biologically balanced system. It's not decoration. It's living infrastructure.
And that really makes you think, doesn't it? It's a system that can quiet our rooms, clean the air we breathe, and even calm our minds. It's this beautiful fusion of nature and technology, and it leaves us with a really fascinating question. What if the healthiest parts of our future buildings aren't built at all, but grown?